We've got students who just finished high school or just finished college, and then we've got students who are returning back to school after a few years away. Okay, so I've got a larger spread in this classroom rather than my other class. Okay, so if we looked at say the range or the IQR or the standard deviation of 1, we would have smaller numbers. Range or IQR of the other class of this one, we would have larger numbers. Okay. We showed box plots and dot plots. I mean, not box plots. Dot plots and histograms. There's also another graphic summary, okay, graphic tool that we can use called a box plot. Okay. And the one that I'm going to draw is what the book calls a modified box plot. But in almost every other textbook, their standard box plot is the book's modified box plot. Okay, so just go learn the modified box plot. Okay, and basically, this is like the Cliff Notes summary of a data set. Okay, it's just used to just kind of highlight the pieces of the thing. So with the histogram, you can see the shape and all of that great stuff. The box plot is just going to go boom, boom, boom. It's just going to show you some numbers, okay? So again, all of these, you've got to draw a number line to kind of set up your scale. And you start off by drawing a box at Q1, Q3, and you put a line at Q2. So you put a line at Q1, Q2, and Q3. Okay? So I'm going to put a line at 7, a line at 9.5, and a line at Q3, which is 10. I've got Q1 right there, Q2, or the median, and Q3 right there. Okay? That forms my box. I create something called the upper fence and the lower fence. The upper fence, basically, I take the width of this box. What's the width of the box? 3. Okay, what's another name for the width of the box?
IQR.
The IQR, right? Q3 minus Q1, that's the width of the box. That's the IQR. I'm going to take 1.5 widths of the box. Okay, so this is one width of the box, and I go 1, and then half of this, so up to here, okay? So I take 1.5 of the width of the box, and I draw an imaginary line called the upper fence. So the formula for where that goes is Q3 plus 1.5 times the IQR. Okay, so in this case, it's going to be 10 plus 1.5 times 3, 14.5, which is, I think, where I kind of ended up over here. So I draw a line right there. This is my upper fence. Or you can call it the UF. All right, and I do the same thing from the other side. Okay, so I go 1.5 times the IQR below this edge of the box, and that's going to give me my lower fence. So I do Q1 minus 1.5 times the IQR. So I have 7 minus 1.5 times 3. So 7 minus 4.5, what is that? 2.5? Okay. And I draw an imaginary line at 2.5. This is my lower fence. Now I draw lines or whiskers that go to the largest and smallest data points that I have that are still within the fences. Okay? So what's the smallest data point that I have here? 3. Is 3 within my fence? Yes. Okay, so I'm going to draw a line that goes down to 3 and it stops at 3. I don't go all the way to my lower fence. The line stops at 3, okay? So line goes to the smallest point data point within the fence. I do the same thing over here. So where does my line extend on the upper side?
Highest point within the fence.
Yeah, the highest point within the fence. So what point is that? 14. 20 and 21 are outside of my fences, so the line doesn't go there. So my line goes up to 14. Okay? So again, this goes to the highest point within the fence. Okay, so what do I do with 20 and 21? I indicate those with either circles or stars. Okay? Some textbooks or computer programs will put a star there. I think our textbook puts circles there. It doesn't matter, okay? You just indicate those there. And so that means those data points are there. And these are listed as potential outliers, okay? Or we can just say they're outliers. Okay. And that's the making of a box plot, okay? Now box plots, okay, it's not just here we're gonna have you do all of this stuff just for fun, okay? Box plots are very useful if you want to compare a whole bunch of distributions, different data sets, and you can compare them relatively easily because you just have kind of this critical bits of information. You got Q1, Q2, and Q3, so you can see where the middle 50% lie. Okay, you've got an idea of kind of the range of the data. It's not really the range because the outliers are kind of separated, but this kind of gives you what's considered, quote, normal. Okay, the things within the fences are considered, quote, normal, and then anything outside of that you also see exists, but might be considered unusual or as outliers. Okay, and so the box plots are very useful in terms of comparing the data points there. Sorry, we ran out of time to go over the standard deviation, but again, the concept behind it is that it's just a measure of spread. If a data set has a large standard deviation, it means the numbers are spread out or very different from one another. If the data set has a small standard deviation, it means the numbers are very similar or close together. Okay, so you have some exercises.
What did you call that line where it started from the 3 and ended at the 14? Like in between the fences?
This?
Yeah.
They're known as whiskers, okay? Whisker. Sometimes it's called a box and whisker plot, okay? Depending on what textbook you read. But box plot.